On the evening of June 1st, 2009, an Airbus A330, an aircraft equipped with one of the most sophisticated fly-by-wire systems in the world to protect it from stalls, plummeted from 38,000 feet into the Atlantic Ocean while being held in a stall by the flight crew for over 3 minutes. The flight controls and engine were operating perfectly. The airplane would have recovered had the pilot simply pushed forward in the control column purposely for several seconds, but they didn't. Why? Hi, my name is Marty McDonough, and I am an advanced instructor pilot and the Chief of Safety at Aviation Performance Solutions in Mesa, Arizona. I'm going to talk to you today about the angle of attack and angle of attack gauges and whether or not that will improve safety of flight in today's aircraft. This is the overview of the things I'm going to talk about. So in 2011, the General Aviation Joint Steering Committee Loss of Control Working Group did a study on all fatal accidents from 2001 through 2010. They found that in over 40% of the fatal accidents, the cause of the accident was loss of control in flight. Also, about the same time, actually a little bit later, Boeing did a study where they compiled all the information from the worldwide commercial jet fleet. They used the Commercial Aviation Safety Team and ICAO Common Taxonomy categories, and the time frame that they looked at was 2004 to 2013. They found that 40% of the fatalities in all of those accidents were due to loss of control in flight. So when an aircraft is upset, when an aircraft can be upset due to an environmental condition, maybe due to the airplane going through some wind shear or hitting some wake turbulence, could possibly be a mechanical malfunction of the airplane, or maybe even a pilot-induced malfunction, maybe the bad pilot technique, or the pilot just inattention to what's going on. But when the aircraft is upset, the number one resulting condition that leads to loss of control in flight is a stall. The airplane stalls, any airplane stalls, when the critical angle of attack is exceeded. Just as a quick reminder, the angle of attack is the angle between the chord line of the wing and the relative wind to that chord line or to that wing. So when that angle of attack is exceeded, the airplane stalls. This is the only thing that makes an airplane stall. It is not correlated with the airspeed, although many pilots know that the stall based upon a stall speed. They think of it as getting too slow causes the stall, but actually what causes the stall is exceeding the critical angle of attack. So in 2011 and 2012, the Loss of Control Working Group finalized their study and put out their report. And in the report, their top 2 safety enhancements had to do with adding angle of attack gauges to aircraft. The first of those safety enhancements said that they recommended that AOA gauges be added to all new design airplane and all airplanes that are currently in production at the time. And along with that, for safety enhancement 2, they recommended that current aircraft owners and current aircraft be installed with angle of attack gauges as well. In February of 2014, the FAA, because of those recommendations, put forth a memo, and that memo allowed angle of attack gauges to be installed in aircraft. And those, not that they weren't allowed before, but it allowed them to be installed under slightly less strict design criteria. The design criteria that was required was under the American Society for Testing Material, the ASTM standard, rather than the stricter technical standard order design criteria. So they allowed that to happen, which does allow for less expensive and easier to install gauges to be installed on airplanes. So that opened the door to the general aviation or to the aviation community to install gauges on aircraft. Okay. The question is that going to help? Will just installing gauges in the aircraft help? So let's take a quick look at some of the designs. There's AOA gauges have been on aircraft for a long time. In fact, especially military airplanes, and in particular Navy airplanes, do a lot of their flying off of angle of attack. It's very, very critical to carrier landings. But there's angle of attack gauges installed in many airplanes these days. There's different types of gauges. One type of gauge, the first one depicted here in this slide, is an angle of attack gauge where 1.0 is the critical angle of attack. So in other words, at 1.0 you are stalled. Usually a gauge like this also has different indications along the gauge that shows the angle of attack to fly for different flight conditions. For example, best range, your approach speed, and other things, other critical data points like that. Another gauge, this one I believe is taken directly out of an F4, is the black one to the right of the slide. And this gauge just actually reads angle of attack either in units or in actual degrees of angle of attack. I believe this one's in units. It also has particular data points that are noted along the scale that show usually in either blocks or triangles or hash marks. And you can kind of see those along that gauge that show different data points. For example, your best range, your best your L/D Dmax, your approach speed, and other ways of depicting those. The third and slightly simpler, easier to interpret gauge is there's gauges with different lights. Those lights usually consist of green, amber, and red lights. Those lights light up in a particular order. Usually green meaning that your angle of attack is relatively low and you're safe. Yellow meaning maybe that you're approaching your approach angle of attack or a critical angle of attack. And then red meaning that you're definitely approaching your critical angle of attack and your airplane is on the way to being stalled. The Bendix King one depicted down at the bottom left of the page is one of those gauges. And in fact, you would get green for a while as you slowed your airplane down to your approach speed. You would then get yellow, and then when that blue donut, as we would call it, is lit up, then you're on your approach speed. So it gives the pilot a good information as to how to fly their airplane on approach. And it is because angle of attack just measures that relative wind and the aircraft in relation to stall, then the airplane can be flown at that angle of attack and without regard to what your airspeed is, because the angle of attack is going to be a much better indication of your actual approach speeds and what you should be flying. But how does a pilot interpret this information? If the pilot just has one of these gauges on his airplane, how does he know what they need to do, where they need to fly their airplane in order to fly their airplane the most efficient way, and in particular, how to recover from upsets using an AOA gauge? So let's talk about training for a little bit. To be fair, with what the Loss of Control Working Group recommended, they didn't just recommend that these gauges be installed in airplanes. They also had some pretty extensive verbiage in their report, stating that the FAA and the general aviation community, or the aviation community, needed to start an education campaign to stress the importance of these gauges, and also a training campaign to train pilots on the information that these gauges actually did provide. So the incident that I started off this presentation with was Air France Flight 447. So if one of these gauges was installed in that airplane, in that Airbus A330, would it have saved Flight 447? And that's a very good question. I'm often asked that as I was just researching this paper. I was asked that about a lot of different things, in particular about a lot of different incidents, and in particular about that incident. And that's all we can never really tell. But in my opinion, in this author's opinion, I think that the outcome most likely would have been the same. That aircraft had a lot of different indications that were telling them that the airplane was stalled. They had a almost continuous stall warning for at least the first 56 seconds, a audible voice warning saying stall, They had other indications telling that the airplane was stalled, but they misinterpreted this information because they had gotten themselves into a position where they were ignoring some of the indications they were getting because they were confused as to what was really going on. And more gauges would have probably just confused them even further, given them more indecision on what was going on. So, what kind of training is required? Well, first of all, pilots just need to know what information these gauges are providing. The industry has come up with a lot of different solutions, and not just since these reports have come out. One particular solution is the training that we provide at Aviation Performance Solutions. Okay, the training at APS here that we provide is extensive on-aircraft training. And we start off with academics, where we talk about what the angle of attack is. We talk about how angle of attack applies to flying your airplane, and we also explain how it is the angle of attack that causes an airplane to stall, and not your airspeed. Now, many pilots, when they are first trained, are taught that. And that's the book answer that they will give you, that exceeding the critical angle of attack causes an aircraft to stall. But throughout their training, they relate the stall to a certain airspeed that they were told to memorize as far as their stall speed. And by the time they're proficient in their airplane, they for the most part, relate the stall to a particular airspeed in their airplane. So after teaching them in academics, after in the classroom academics talking about angle of attack, we then go out on the aircraft and we actually perform a few maneuvers showing exactly how angle of attack is affected as different maneuvers are performed. And for the most part, for the students that we fly with, we find that they see this relationship actually in the aircraft for the first time, and it for the first time truly makes sense to them as to what is going on. There's also other things that have come out, other different training and different developments that have come out throughout the last several years since these recommendations have been made. One company in particular, the company Alpha Trainer, has developed some software that they add on to the X-Plane flight simulator. This software then depicts a graphic representation of the angle of attack on the wings as the pilot flies the aircraft, and so it shows the pilot exactly how the angle of attack is behaving, how the angle of attack is affected, I should say, as they fly their airplane in different flight regimes, and it can give them a really good sense of how they need to fly their airplane in order to either recover it from an upset or to keep it from getting to an upset altogether. So, in conclusion, the biggest question you got to ask yourself based on all this is, will just installing angle of attack gauges make flying safer? Well, we would hope that it would, but unfortunately, because most pilots don't really understand what information is being given them when they have an AOA gauge installed in their airplane, I think that installing AOA gauges on airplanes can make flying safer, but the right gauges need to be installed, the ones that are easy to interpret and give the pilot the appropriate information that they need, and the pilots need that training, the correct training, to really teach them how to interpret that information and what to do with that information once they have interpreted how to fly their airplane in order to then recover their airplane, or actually the bigger goal would be to avoid the upset in the first place, to keep away from the stall and not let their airplane get out of control. Thank you for your time today. I hope you enjoyed the presentation, and have a nice day.